So today we will see some of the basic principles of radar communication. So the contents of this video lecture are introduction, basic principle, important terms, types of radar, basic radar block diagram, Doppler effect, MTI radar and applications. Now radar, what actually radar mean? It is radio detection and ranging. So radio means here radio waves are used for this process. Detection means to identify the target and ranging means to find the distance or position of the target. So the founder of the first practical radar is British physicist Sir Robert Watson Watt in 1935. But the German physicist Heinrich Hertz is called the father of the radar. So this radar waves or radar is actually used to detect targets. It is used in war and such type of things where we have to detect targets. For this, radio waves are used for the purpose and radio waves will detect the target. Now the basic principle is the principle of sound wave reflection. We know that sound waves reflect from objects. Similarly in radars, radio waves are reflected by the objects. For example, if you shout in a direction of a sound reflecting object, you will hear an echo. Similarly, radio waves will be reflected by the target. If you know the speed of the sound in air, you can then estimate the distance and general direction of the object. Now, this figure shows the basic principle of radar. We have transmitter or receiver antenna. And the same antenna serves for both purposes, for transmitting and receiving radio waves. So from the transmitter, radio waves are transmitted, which are shown by those red lines. And radio waves are traveling towards the target. Here our target is an aircraft. And from the aircraft, or this radio waves, after striking the aircraft, are reflected back. And the reflected waves are shown by green lines. So the distance between the transmitter and the target is called actually the range of the target. Okay. So transmitted waves are sending to the target. Target will reflect the waves and they are also known as echo waves. So this block diagram shows the basic principle behind radar. We have the transmitter receiver. Same antenna serves as transmitter and receiver. Then we have from the antenna we have the transmitted signal towards the target. And from the target we have the received signal, and the distance between the transmitter and the target is called the range. And at the receiver, the received signal is analyzed and we can find the range of the target. Range means distance of the target. So the important terms here we use are range, pulse repetition frequency, maximum unambiguous range, minimum range, clutters, etc. So range. So distance between radar and target is called the range of the target or simply range R. So we know that speed is equal to distance by time. Distance is speed into time. So distance is the range here. So time is the time taken for the waves to transmit to the target and return back. So if R is the distance between the transmitter and the target, then total distance is 2R, to and from motion. Transmitted wave and reflected wave, to and from motion. The total distance is 2R. And c is the velocity of radio waves, which is the velocity of electromagnetic wave, and T is the capital T is the time taken, so that we have range R is equal to C into T by 2. Next we have pulse repetition frequency. We have the time interval between the two successive clock pulses, that is two successive clock radio waves, is called the pulse repetition time TP, and the reciprocal of this pulse repetition time is called pulse repetition frequency FP. So mathematically it can be represented as FP is 1 by TP. Now what is maximum unambiguous range? So we will get an idea, or we can clearly measure the distance of the target if the next signal is transmitted after receiving the first echo signal. Means, suppose we are transmitting a signal and the echo is received, and then only next clock pulse will transmit. In that case only we can efficiently measure the range of the target. So we have to select the duration between the two clock pulses in such a way that the echo signal corresponding to present clock pulse will be received before the next clock pulse starts. Then we will get the true range of the target, and it is also called maximum unambiguous range of the target, or simply maximum unambiguous range. It is given by RUN is equal to C by 2 FP.